one last set of z-score problems. Suppose the mileage on cars is normally distributed. Some cars have a lot of miles on them, some cars have very few miles on them, but the majority of cars have an average. It sort of forms a bell curve if you made a histogram of all the car mileages of all the cars in the world. And the average, the mean car was, let's say, had 114,000 miles on it, and let's say the standard deviation is 34,000. Then what we've got here is x bar is 114,000, and the sigma is 34,000. Okay, what percentage of cars have less than 50,000 miles? Now we're talking about a data point of 50,000. So what we want is the z-score is 50,000 minus 114,000 divided by 34,000, which is something I need a calculator for. 50,000 minus 114,000 divided by, let's try that again. Because you see what I was going to do? I was about to say divided by equals, and it was only going to divide the 114,000 by the 34,000. I have to do the 50,000 minus the 114,000 and hit equals because of those invisible parentheses across the top. Then I divide by 34,000, and I get, negative 1.88. Negative 1.88. Here's those invisible parentheses I was just talking about. If I just typed in, I was going to type in 50,000 minus 140,000 divided by 34. The calculator was going to divide just this one by 34, and I was going to get a number, very close to 50,000, and it would be way off the chart, and I wouldn't be able to find it. Negative 1.88 on the chart. Okay, I have to go up to the negatives. Negative 1.8. Here's negative 1.8. The question is negative 1.88. I remember on this particular chart it goes the other way, so this is negative 1.89, negative 1.88. So it's 3.01, about 3% of all the cars. So this is 3.01%. So I made up these numbers. That seems a little bit unusual to me. I think that there would be more than 3% of the cars out there have less than 50,000 miles on it. Although, I don't know. They always pretend that you're getting 10,000 miles a year on a car, but people put about 20,000 miles a year on their car, and people who commute put even more on that. So this is like how many cars out there are less than 3 years old, and anyway. Getting this data is remarkably hard to find the average length of a snake and what the standard deviation is, what the average IQ is, or what the standard deviation is. Really, really hard to find this data. I mean, I've done an internet search for this and had a lot of trouble. Remarkably easy to just make up numbers off the top of your head, and that's what I do. B. Now it's a little bit tricky. What have we got between 50,000 and 100,000? So what we want is, we need the z-scores here. If x is 100,000, because we've already figured it out for 50,000, for 100,000, the z-score corresponding to that is going to be 100,000 minus 114,000 divided by 34,000, and that is 100,000 minus 114,000 equals, divided by 34,000 is negative 0.41. Negative 0.41. And negative 0.41 on the chart is negative, is this one is 0.41, the last, second to last, the penultimate column. So negative 0.41, right up here. Negative 0.401, 34.09. So this is 34.09, but be careful, because what we've just figured out is, what does that number mean? That means everything up to 100,000 miles is 34.09. But we want everything between 50. So everything up to 100,000 miles is 34.09. The 50,000 was 3.01. 3.01. So, but we wanted, if we go back up to the question, what percentage of cars have between 50,000 and 100,000? We just want in between. And for that, hopefully it's clear, we subtract. This is going to be 34.09 minus 3.01. Ha! No borrowing even necessary. 31.08%. So about, if my numbers make any sense, and maybe they don't, if the mean is 114,000, if the standard deviation is 34,000, then the number of cars with a mileage between 50,000 and 100,000 is roughly 31%. And this is how you use z-scores. And it's a really great way. If you are doing psychology, so often you say, oh my goodness, people said this. Is that unusual? Oh my goodness, this happened to this person so many times. Is that unusual? What does the average person have? What's the average number of whatevers? And if you know the average, the mean, if you know the standard deviation, you can put everything in terms of z-scores, and then this table works, assuming that it's normally distributed. If it's not normally distributed, who knows? So that's it for today.